Okay, I would like to talk a little bit about voltage doublers and a 120 volt voltage doubler and a 240 volt bridge circuit as seen in this drawing. So, uh, your line and your neutral come in on the left side over here. Line on the top, neutral down here. This is a switch mode power supply, so it has these components in here to cut back from high frequency noise getting back on the line. They don't want it to put noise out back on your line, so they have that stuff there. So your line voltage and current come in here. Well, first what has to happen is you turn your switch on. This is a QSC PLX 1602 amplifier. Push the on switch, closes between these 2 points here, and on a healthy amp it starts drawing current, and this resistor starts to heat up, and it starts at 10 ohms and it goes down from there as it starts heating up. And then this coil here on this relay here has a few protect circuits that are involved down here, and if everything is kosher, it likes everything, it will close, and it will short circuit this thermistor right here. And then now it's 0 ohms because it's short circuited anyway. So now we have good healthy line voltage appearing coming into this network right here. What the heck? All right, so then you have your line voltage right here and neutral right here. Now my amp is configured for 120 volts. My amp is configured for 120 volts, so I have a short between. I have a jumper on the circuit board, just jumpered here and here. I have the 120 volt doubler circuit engaged. So on the positive half of the first sine wave, it is traveling with reference to my neutral. This is positive. Comes this way. Actually, it can hit this spot here too, right? Comes around here, it appears here and here at the same time. Points 2 and 3 on that bridge. Forward biases both of these diodes and appears on pin 1. Comes up over here in a positive half of my sine wave, the 120 volt sine wave, peaks at 170 volts, and we'll charge this 200 volt capacitor here with 170 volts. Now, when in this 120 volt jumpered situation here, my neutral is down here and is over here, which is basically the bottom of the top caps. So we have it charges on the positive half of the sine wave, it charges the upper caps to 170 volts. Now 180 degrees of rotation happens, and now we have the negative half of the sine wave. But I like to think of things when I'm doing this as positive. So, I mean, it is positive on the negative half of the sine wave if you reference to this spot here. If I reference here, this is just another positive pulse, right? So it's positive, comes over here, and it on the second time portion of the sine wave, I am charging these caps to 170 volts, which is referenced to PRI low. PRI low is over here, same spot as here, and that positive pulse is now forward biasing both of these diodes, and the current returns to this side up here, where the other side of your AC supply. So on the voltage doubler circuit, the first half of the sine wave, I don't like using positive and negative, let's say the first half of the sine wave, I'm using these two diodes. The second half of the sine wave, I'm using these two diodes. I develop 170 volts across these caps, and I developed 170 volts across these caps, and my circuit is referencing everything to PRI low. If you take your digital multimeter, put it on DC volts, put your black lead down here, go to this spot here, in the middle here, I'll have 170 volts. Leave your black lead down here, go all the way up here, you will have 340 volts. Thus, you've created 340 volts DC from a 120 volt AC line input. So now, give me a second here. Let me erase this. And we're going to put the 240 volt jumper in. We will remove this one, and we will remove this one. We're going to draw this one in. Now we have 240 volts line coming in right here and right here. 240 volts. So the positive half of this, the first 180 degrees of the sine wave starts going positive, travels right here, starts going positive, forward biases this diode. Can't go this way. Can't go this way. It's got to forward bias this diode, comes up here, 240 volts AC, which is 370 peak. It's going to start charging this cap, but it's also connected to these caps with reference to PRI low, and we have 340 volts starting to charge on these two caps sitting on top of each other. And the reference is PRI low, so that's the reference this time. So we got to grab it over here. PRI low comes up this way, and it's a positive pulse. The current is traveling positive direction, so it uses this diode and comes back this way and finds its return. So in the 240 volt bridge, first half of the cycle, we're using this diode and this diode. Now, on the negative half, or the second 180 degrees of the AC signal, I'm going to reference here and measure down here, and it's once again, it's a positive pulse. It comes over, it's a positive pulse, and it's traveled through my little jumper here, comes around over here, hits this spot right here, goes through this diode, comes over here, charges up the caps to 340 volts DC, referenced all the way down to PRI low, comes over here and uses this one to get back. So you see on the bridge, 240 volt bridge, I'm using this one and this one on the first 180 degrees. In the second 180 degrees, I'm using this one and this one. There you have it, the two modes of operation of the voltage coming in to the switch mode power supply. Next up will be a discussion of the next video. I will start getting into the meat and potatoes of this bad boy. the switching of the power FETs, or the IGBTs. We'll start getting into that, and stay tuned.